Hi, everybody. Thank you for joining us for our webinar, Silent Saboteurs. We're going to talk about supply chain attacks specific to mobile app security. We're going to discuss some differences and some interesting variations as it pertains to mobile. And of course, we'll talk about some mitigation strategies. I'm your host, Ilya Draitser. Great to be here. I'm the VP of Solutions Engineering and Customer Success. I've been with Quokka for almost 4 years, and in that time, I worked with many of our customers and many of our POC and pre-sales engagements as well, getting to know the different types of mobile security risks that are important to folks. So very happy to be here. For those of you joining the webinar, there is a chat feature. If you're going to ask any questions, definitely just type them in and we'll address them at the end of the webinar. This is a 30-minute webinar, so time flies. I'll try to cover the material as quickly as I can. But I'm very excited to talk about supply chain as it pertains to mobile, because it is actually a very fascinating space with a lot of interesting variations compared to traditional software development. And I started out as a software developer for a large legacy computer-based system for the military. And so, talk about supply chain, right? But mobile is a little bit different. So today on our agenda, the first thing we'll do is just define the supply chain and specifically how it pertains to the mobile ecosystem. Mobile being, Android, iOS. So it's your iPad, it's your phone, it's that TV that's running Android in the background, it's the smart assistant that's running Android. It's all sorts of devices that, broadly speaking, fall into the mobile ecosystem. And then we'll talk about specific threats, right? And then, of course, the last thing we'll do is discuss some mitigation strategies for each type of threat. So as we go through this, I hope what you discover are some different ways of thinking about just how vast the supply chain is on mobile and how different it is from traditional computer programs, right? And again, please, if you have any thoughts or questions, do type them into the chat. We'll take a look at that at the end of the webinar. So the big thing in the news right now is this self-replicating NPM package worm that's trying to steal credentials. And the scary thing is it's self-replicating, and NPM packages are applicable to everything, including mobile, right? Many mobile apps actually embed web-based technology, JavaScript inside. So some of these packages are actually being used directly in mobile, but they also affect the overall development system on which the mobile apps are written. And so there's some intricacies there. Another supply chain attack with the Ruby gems, that affects Telegram, which of course is a mobile app, but it's kind of affecting the back end. But the supply chain on a mobile application also can compromise secrets. It can extract, this OCR attack, which we'll talk a little bit about more later. And all of these things are in many ways enabled because there is such a thing as a software supply chain, right? So what is a software supply chain? Well, a very simple definition would just say it's the components and the libraries and the tools and the process, to publish software, right? And I think that's a very simplistic definition. So I found a better one from these guys at Circle CI, not affiliated with us, but very good CI/CD system. Um, it goes into a little more detail because it talks about everything, right? The source binaries, the proprietary source binaries, the building orchestration tools, which is where the NPM attack sort of lives, if you think about it. It's sort of it even encompasses the people, the organizations, and even the processes that are involved in software development. So if we take that definition and we tie it to a mobile user, right? I'm a mobile user. I have a mobile device and I use it for work. Okay, so what's my supply chain? Well, actually, the first place you need to think about is the device itself, right? And of course, we have Apple devices and we have Android devices. And when you think about the supply chain between Apple and Android, they're very different, and the risks are fundamentally different. So first, look at the Apple ecosystem, right? They own everything, the hardware, the software, the third party, the chips, everything that's in there essentially goes through Apple. And there's no real good way for third parties to, scan the device and identify any problems, right? So Apple's mentality is they don't disclose or really confirm any security issues until they had a chance to investigate and they patch it or a release is available. So, as usual, pros and cons, right? The supply chain for Apple is very closely guarded by Apple. And so we don't see a ton of risks the way we do on Android. But the downside is when we do see risks, they are actually kind of hidden away. So there was an emergency patch that Apple issued for a couple of zero-day vulnerabilities, which were exploited, and they were exploited in an extremely sophisticated attack. Well, what this article doesn't tell you is that this fundamental flaw that Apple fixed was actually in the device for years before someone found it. So what that means is arguably Apple's security is more secure than, say, an Android device in practice. But on the other hand, if somebody does find a zero day and they don't tell anyone about it, they can use it, meaning they, the bad guys, can use that zero day to do things for potentially, years until either Apple accidentally discovers it or it somehow gets enough traction that someone becomes aware of it and Apple has to go fix it, right? So there's sort of pros and cons. On the other hand, with Android, Linus rather said the whole thousand eyeball theory, right? The idea is that because it's open and it's open source, lots of people can look at it, researchers can attack it, and potentially we're going to find a lot of things faster. And again, pros and cons, right? There are a lot more attacks that you see on Android, and it's a much more fragmented ecosystem. Why is that? Well, let's look at what an Android device really is, right? It's comprised of a bunch of open source, which is coming from Google itself, right? The open source Google project. And then you have some, Java specific API frameworks, and then you have these system apps. So when you think about the supply chain on Apple, it's closed, but when you look at an Android supply chain, it's actually very open, which means anybody, any researcher, anybody out in even industry can go out and scan and find these issues. So what we are talking about specifically with the supply chain here is when you consider an Android device, it basically consists of chipset, right? Radio, like the actual hardware that's coming from some manufacturer. Well, that hardware has software associated with it, right? The camera driver, the GPS driver, the Bluetooth driver. These are all essentially apps. And they're part of the supply chain because they're coming from some third party. And then you have the vendor, Lenovo versus Samsung. They're putting their own apps on top of it that live up above or inside the system apps layer. And then on top of that, you might have carrier apps. So if you're with Verizon versus Orange, they're putting their own apps on it. So all of that is the supply chain. So one example of supply chain affecting a regular user would be this thing from Qualcomm. So Qualcomm makes a chipset that goes into phones, in this case sold primarily by Nokia, but actually exists in lots of different phones. And there is a problem with this particular workload classifier, which is an app that by definition makes it part of the supply chain. And the problem with this app is that it's actually leaking it's leaking the package name or the name of any app that you start on this device. So it's essentially taking private information, which apps are you running on your device, and it's leaking that to an attacker, which can then exfiltrate that data. And this is a pretty mundane example of what happens when there's a security flaw inside an application, which is bundled with the phone. And that's what I'm trying to communicate here is that the first of three types of supply chain that you have to consider about a mobile device is all the apps that sit on that device before you even turn it on, right? So mobile supply chain from a device level is one consideration. Then there's the traditional mobile app supply chain. So I'm a developer, I'm designing a mobile app. Well, I'm not building all the source code from scratch. I'm using third-party libraries, some of which have, some of which might be proprietary, some of which might have an Apache license or an MIT license. And so there's actually in the US, there's an executive order to improve the nation's cybersecurity, which basically defines the software bill of materials and says that, they need to be provided, they need to be evaluated. And not only is the SBOM itself, which is the formal record containing the details of the supply chain, not only do we need an SBOM, but we also need to identify any risks inside that SBOM. So this is the traditional, if you will, thought about software supply chain for an app. So you're building an app, you have some third-party libraries, you need to produce a software bill of materials, and then you need to identify any vulnerabilities. Now, there's two ways to do that. So let's talk about mitigating strategies, right? So Cyclone DX is an industry standard for actually listing or creating that supply chain, list of issues, right? So um, the way you generate that is using either a static tool like a software composition analysis tool, which is usually static analysis. It's usually driven by the source code itself, right? Or a binary scanner, which actually takes the finished product, the mobile app itself, and then analyzes it and identifies bill of materials from that. So if you think about it, there's pros and cons to this. I love pros and cons, by the way. The pros to SCA is that they have full visibility of everything that's going in the build. So they know exactly what they're including as they're building the app. And so this is really good if you are the developer and you want to generate an SBOM to send to your customer. Brilliant. This is a good way to go. The downside is it doesn't show you what's inside each of the packages that you're including, right? So anything that say you're using a proprietary third-party library, it will show that you're using that library, like this UITH guar lib here, but it won't tell you what it consists of. Because of course, each of these is probably using a bunch of other libraries, right? And it kind of goes on forever. So a binary scanner, the pro of a binary scanner is it looks inside the binary of the mobile app. So it can see everything that's in there. It doesn't matter if it's included directly as part of the build, or it's a subsection of another build, or it's some proprietary library. It looks inside everything and it tells you what it found. And the downside, of course, is that it's doing it by essentially trying to match up what's in there. So it's not perfect. So one way to look at that is something like this, right? Where you can see, okay, for this particular mobile app, we have these packages, we have, the Android X, we have, this one, we have that one, and then a couple of them actually have vulnerabilities, right? And so this qualifies as a binary scanner, which looks inside the app and tells you, oh, this app consists of the following libraries and packages, and of them, some of them actually have vulnerabilities, and here they are. So that's good. That's an example of a binary scanner showing you not only what's included at build time, but also what's sub in there. And the other nice thing about it, and this is also part of that executive order, and of course there are parallel orders in different countries, right? The UK has a different one. There's actually a good listing over here of some things, the Cyber Resiliency Act in the European Union that recently launched. So these are all good things, right? These are essentially cross-referencing a known database of threats and saying, this particular library uses, this particular JSON library version 2.8.9 is vulnerable to this issue, and here's the CVE link. So this is a link to an external database where we can go and check what the problem is. However, this information could be, weeks, months, even years old potentially. So these are threats that have already been discovered against some of these third-party libraries. But what about vulnerabilities or weaknesses that exist in those libraries which no one has discovered yet? Well, the nice thing about a binary scanner is it can actually show you that. So here's a different example of an iOS app from the App Store. And when we look at the details, you can actually see that this particular third-party library, GTD Mob SDK, is using a cipher in ECB mode, which is insecure. And the differentiation here is this is in the third-party code and this is in the app code itself. So by scanning the binary, not only can we identify libraries which are already known to be insecure, but we can actually find new vulnerabilities or insecurities which we can highlight. So a binary scanner like this one will find these things. Here's another example, contains hard-coded keys. So here's that same GDT Mob SDK library, which is actually using this particular hard-coded key to do some encryption. So by using a binary scanner, not only can you detect issues that have already been found and logged against some of these third-party libraries, but you can actually identify new potential vulnerabilities, which could be remediated by the developer or by the developer of that library. So again, if you're building a mobile app and you're concerned about, or your job is to put together that SBOM, it's part of your job to also ensure that vulnerabilities or weaknesses are identified. And so there's these two different approaches, which have both have pros and cons, which you can use to identify and ultimately fix, or at least publish for your customers, that information. And so this is the traditional look at the supply chain on a mobile app. Now, previously, we talked about mobile apps which come with the device, right? So you have to worry about that too. On Apple, there's not much you can do about it, but on Android, actually, you can do a lot because you can scan the device and actually find those issues. And so if you want to look at a typical Android device, here's a scan of a device and it has a bunch of issues. And we can actually do this because Android is open. We can actually scan, the Android device and find out that it's leaking credentials or that it's leaking SMS messages, right? That's particularly concerning because again, if this app is part of the, on device, it comes bundled with the device, so to speak. That's a problem. And that's exactly what this is. It's basically the telephony app that's pre-installed on this phone that's actually creating a log of the full content URI of the SMS message. So this is an example of something that's part of the supply chain. This is an example of something that's part of this particular app's supply chain. But the last thing I want you to think about is, as a user of a mobile device, what do you have on that mobile device? Well, let's say it's a work device. Maybe it's a phone that you use for work. Maybe in a factory setting, it's a tablet. If you are in a retail or hospitality or healthcare, mobile is everywhere, right? You have tablets that are being used by pilots. You have tablets that are being used by doctors. So all of these mobile devices, what does their supply chain look like? And so if you put it all together, you have the device itself, you have the software on the device, you have the mobile app itself. This is where mobile risks are leading to data breaches and they're leading to actual risks for us as individuals, for us as employees of a company, for us as folks that work in a government setting. These are the kinds of things that we're seeing, right? Different apps or device flaws that are essentially turning into real damage, financial damage, or PII damage, or IP theft, that sort of thing. And what is that supply chain? Well, it's all the apps on the device. So if I think about my phone has about 180 apps. I think the average these days is listed as about 80 to 100 apps. And again, we use our phones for work, or they might be dedicated work phones with, let's say, 50 apps on them. But what are the risks on those apps, right? They may seem safe on the surface, but they have all sorts of hidden risks. They might have malicious behavior, like those OCR Trojans that are trying to steal, credentials and crypto keys. They might have privacy risks, like leaking your SMS messages. If you're a journalist, or if you're, HIPAA compliant, situation, or even academic schools, there's lots of things you don't want to leak. Unvetted apps and shadow IT, right? These are all things that potentially are risks. And I'm saying they're part of your supply chain. Ultimately, you as a user have a supply chain of each app. Each app has its own supply chain. Together, taken together, they are on your device, combined with the apps on the device. That's your supply chain, and it has risks. So let's talk a little bit about what those risks really look like in the real world. So this came out last year. There was about 107 malware variant samples. And so it's the same malware, but it's repackaged slightly. It's changed. It's changing its signature. And so Google Play Protect does a great job of scanning and finding known malware. But what happens if the malware is unknown, right? What happens if no one has figured out yet that there's a 0-day and it's exploitable to steal your credentials or to identify the hard-coded keys in the app, right? So that's something that is a real problem with both Google and Apple, frankly. And this is something that we need to be concerned about as users of these devices. So, what can you do about that? Well, if you can get the app intelligence at the device level, then you can take each of those apps and very quickly both identify the SBOM and also identify the risks. So what you see here is essentially all the apps installed on a particular mobile fleet. And those apps, they're downloaded from the App Store, or maybe they are pre-vetted by the organization, by the enterprise, and provided through some kind of mobile device management system. So these apps have their own, each one has its own SBOM, right? Each one has its own risks, and we can categorize them based on these policy violations. So when you start looking at the fleet view, you realize that your supply chain as an organization is all the apps on everyone's devices that are part of your user base or your network. And so each one of these, if you look into the detail, you can get, for example, the SBOM, or you can get the security overview of those things, like we showed earlier, right? So the idea is when you start treating your entire fleet of mobile devices as a question of supply chain, you realize very quickly that if you have automation in place, you can actually pull in the threat intelligence for each app, for each SBOM. And so this helps you meet compliance. This helps you mitigate the risks of the apps. And we can go all the way down to the device level. So to summarize what we talked about so far, the mobile supply chain actually includes everything from the device itself all the way to the apps that we are using as users. And when we look at the details, so for open source components like Android, iOS, in some cases, you have some libraries that are open source that are part of the applications, right? But not really at the device level. On the hardware and software components, like the mobile chipset, right? Or the pre-installed apps that come from the carrier or the vendor, those are definitely part of the supply chain from a user perspective. And then when you're building mobile apps, you as a developer are very concerned about the libraries and frameworks that are being used, both iOS and Android, and both third party, meaning open source, versus third party proprietary, which you're getting as a blob. Now, one story I can share with one of our customers last year out of the UK actually had this issue where they saw that one of the apps that they depend on is actually communicating with all sorts of bad locations, Iran and Russia, and blocked, like places that they're not allowed to talk to as a government agency, right? And when we looked into it, the problem existed in one of the third-party libraries that the developer used because they were using it in a pre-built mode, meaning they were not using an open source library in this case, but they were using a proprietary paid library that was being delivered to them as a binary. So they couldn't actually use SCA tools to see what that library consists of. They couldn't identify the risks in the library because it was pre-compiled. But what they ultimately were able to do with binary scanners is to understand that that library actually has a bunch of code which may or may not actually be used at any particular moment in time, but which potentially is in there and has the ability to communicate with all these locations, including everything from government entities to like a messaging board somewhere in a Russian speaking country. And as a government entity, that's a risk they couldn't tolerate. And that was part of the supply chain of an app that they were using. And it was part of the supply chain from the app developer's point of view. And this is how you have to think about these mobile devices. If you think about it like, Legos, you have all these different Legos that are being used to build these different components. They all stack together into the final product, which is your device with a bunch of apps on it. So the libraries that are being used by the developers, the apps that are installed on the devices, whether they're coming from the official app stores or from third parties, these are all things that are part of the supply chain. So what are the risks specific to mobile? Well, one is intentional malware embedded in the device, whether it's embedded in the app or in the build process, like we talked about the NPM thing, which is hot in the news right now. That's essentially a supply chain attack at its core on the tooling, right? So the packages are being infected with a worm that has this malicious capability to steal passwords. They're then being distributed to developers unknowingly, who are then including them in their own apps, who are then ending up on a mobile device. And that's the flow of that supply chain. The other thing we find is, pre-installed apps on a phone have security vulnerabilities and weaknesses just like any other app. And it's very important to realize that because those apps that are pre-installed on your device, you cannot get rid of them. You cannot update them. Only the phone manufacturer can give you a security update. And they potentially are exposing you to things like full takeover of the device with a text message. And these are all things that can be found if you do device level analysis, using a binary solution. And the last one, of course, is the mobile apps installed on the device, because all the reasons we just talked about, all of those things that are part of the supply chain end up inside a mobile app that you as a user are installing on your device. And do you know what it does? Do you know what its libraries are doing? Do you know if it has any interactions with your device? These are the thoughts on the supply chain. And so if you take this view that a supply chain is actually much broader than just a single developer using a single library as part of their app, and you extend it out in both directions, what are the mitigating strategies? So first of all, we can test devices. We talked about Apple versus Android. Apple has their own way of dealing with security, but any Android device, whether it's a tablet or a phone or a smart whiteboard, a television, a TV box, these are all things that can be tested using binary scanners to identify risks. And so I'll show you an example of one of our customers doing that. Another thing you can do, of course, is perform app scans on the software installed on the device. And if you're the developer, you should definitely be using various technologies, including SCA and binary scanners, to identify and remediate potential vulnerabilities in your own code, but also in the third-party libraries. And we talked about that. That's probably the most obvious thing to do. But then, as a user of a device, right, as a healthcare organization that's rolling out 10,000 iPads or 10,000 Android-based devices to the floor of the hospital, what are you doing to understand the risk posed by the mobile apps on those devices? Do you trust that every developer used all sorts of tools to identify and fix third-party risks? Or do you want to be aware of what's in there and make decisions about whether you should use this app or the other app, right? That are part of this mitigating strategies, because tools exist to help with this. So, Quokka, what do we do to help? Well, we do those four things that I just talked about, right? The device level analysis. Orange is actually sending us phones before they put it into their store to make sure that the entire device doesn't have any, issues, because they see that as a supply chain risk to them launching that as their flagship phone. Android firmware scanning. So Promethean is one of our customers that's using this to ensure the security of their Android-based devices, which they're then shipping to, education space, schools, etc. Pokemon is using us to run the SBOM and security scanning for their device. And the government in the US, the UK, and other places are definitely using us for that enterprise app intelligence scenario that I talked about. And so this is how Quokka can help you with these four different areas of the supply chain, depending on which of them you sit in. But ultimately, it's the app intelligence that sort of covers all of that together for you as a user. So I hope this was helpful. Let's see if there are any questions that we can answer. And if not, then we'll just conclude the webinar and move on. So anybody who's in attendance, if you want to, send us your questions at a later time, we're definitely available. We are happy to do a demo. We're happy to engage with you and answer any questions. Thank you very much for those who stayed to the end, and have a wonderful day.